Hello students, let us solve the ninth question in this paper. So we have a sketch of a design for a logo and it has a rectangle of base x centimeter, height y centimeter with two quarter circles of equal radius of r on the top with a gap of 10 centimeter between the nearest point of each quarter circle. And the first part is asking us to show that the area is given by xy plus pi by 8 times x minus 10 the whole square. Okay. So it's a simple question. So we have a rectangle and then we have two quarter circles, right? So rectangle I indicated by r. So the area of the rectangle is simple length multiplied by breadth. You'll get it as xy. So that gives you the area of the rectangle. Now for the quarter circle, both are equal. So we know that the area of the quarter circle is given by pi r square divided by 4 because it's just a 1/4 of the whole circle. So if it would have been a circle, this would have been the whole circle, and that circle was divided by 4. The area of one circle is pi r square, so of a quarter circle will be pi r square divided by 4. Okay, now, but they are asking you to prove it as this much. That is, they have replaced the r in terms of x. Okay, so let us see how we can replace r in terms of x. The basically x is equal to the sum of r, 10 and another r, that is r plus 10 plus r, or you can say that it is equal to 2r plus 10. So we need to replace the r in terms of x, so I can make r the subject of the formula here. I'll get x minus 10 whole divided by 2. So this over here I am going to replace the r by x minus 10 the whole divided by 2. Then I have to square it and divide it by 4. Okay, so this is equal to pi times x minus 10 the whole square divided by 2. The whole square is 4, and 4 divided by this 4 will give you 16. Okay, I'll just do it in 2 steps. So now I have to do pi times x minus 10 the whole square divided by 16. Okay, so this is each quarter circle. Now if I take the area of both the quarter circle, I have to multiply this term by 2. So the total area will be this plus this multiplied by 2, which will give me pi by 8 times x minus 10 the whole square. Okay, so the method mark the method carries the first mark, and the method includes especially the concept where you are including or considering the relation between x and r. That is the method mark, and the final mark is for the obtaining the correct expression as that is asked to show. Okay. Okay, now in the second part of the question, they are saying that the total area of the design is given as 1 square meter, and the perimeter is given by p is equal to 2y plus 2 plus pi by 2 x minus pi pi. So the perimeter is nothing but the outer length, the total outer length of this design, which is the region that I've drawn over there right now. Okay, and then we need to show that this is the perimeter. So if you observe the two equations, you will understand what needs to be done. So here you can see that this is in terms of y and x, and of course pi is a constant, but here you can see that only there is x terms. The y terms disappear suddenly. So basically you need to express the y in terms of x, for which you are given this condition, that is area is equal to 1 meter square. Okay, and the area expression is also given here, and but here the area was in centimeter square. That is a very common mistake that most of the students make. So the area should be converted into centimeter square. It should not be in meter square, and that expression we use to make y the subject of the formula in terms of x. Okay, so that was the steps I explained. We will discuss it one by one. So first of all, we'll equate the area to 1 square meter, and we will find out the y in terms of x. Okay, so area is equal to xy plus pi by 8 multiplied by x minus 10 the whole square, and area was given as 1 square meter, and 1 square meter is nothing but 1 meter multiplied by 1 meter, and each meter is equal to 100 centimeter, right? So 100 centimeter multiplied by 100 centimeter, which will be 10 to the power 4, or uh, that is 10,000 centimeter square. So this is 10,000 is equal to xy plus y pi by 8 multiplied by x minus 10 the whole square. I need to make y the subject of the formula, so I bring this term over here. So I have 10,000 minus pi by 8 times x minus 10 the whole square is equal to xy. So I can divide the whole thing by x to get y. So this is the expression for y, and now we are given the perimeter equation already in terms of y. So that is p is equal to 2y plus 5 2 plus pi by 2x minus 5 pi. So here I'm going to replace it by this for y. So I'll be getting 2 times 10,000 minus pi by 8 x minus 10 the whole square divided by x plus I'll expand this term also because we can collect the like terms later on. So 2x, and then that is pi by 2x, and then minus pi. Okay, in the next term also I need to expand it, then only I'll be able to collect the like terms, because here you can see that it is of this format, no? So divided by x terms I need to collect it, and multiplied by x terms I need to collect it separately. So this, when I multiply by so I'll expand the inside part, that is this part, then I'll multiply it by 2. So 10,000 minus pi by 8 x square minus 20x plus 100 the whole divided by x. So that divided by x I'll take it outside. Okay, and then we have plus 2x plus pi by 2x minus 5 pi. Now I can open the inside bracket first of all, and then I'll open the outside bracket. So I have minus pi by 8x square, and this will be plus 20x pi divided by 8, which when simplified I can divide it by 4 on both sides. So I'll be getting, okay, I'll do it in the next step. It might be a little bit confusing for you when you check it again. So minus 100 pi by 8, and then I have plus 2x plus pi x by 2 minus 5 pi. Okay, so I'll multiply it and later on I'll simplify it. So this is 20,000 over x minus 2 pi over 2 pi x square over 8x plus 40 pi x over 8x minus 200 pi over 8x plus 2x plus pi by 2x minus 5 pi. So first I'll cancel off whatever we can cancel it over here. So these two terms cancels, these two terms cancel, that's it, right? And then we can simplify it now. So now we can simplify it. 2 and 8 I can put it as 4, 40 and 8 I can put it as 5, 208 I can put it as 25. So these are the simplifications that are possible. Okay, now I'll rewrite it. So this will be 20,000 over x, and this is minus pi by 4x. I have plus 5 pi minus 25 pi over x plus 2x plus pi x by 2 minus 5 pi. So this minus 5 pi and this plus 5 pi gets cancelled. Now if you observe the thing that we need to prove, the divided by x terms are all together and the multiplied by x terms are all together. So I'll do the same thing over here. I have I'll highlight it in orange the terms that are divided by x. These are the only two terms that are divided by x. So I can, what is common here, it is 25 that is common. So 25 by x, or is it required 25 to be taken in common? No. So we can write the whole thing like that. So 20,000 minus 25 over x. So these two terms are taken into consideration. Now we can actually combine these two terms, the green terms, I'll mark it in green. So these two terms, so minus pi by 4x plus x by 2 will be giving plus pi by 4x. Okay, and then we have a 2x. So this here, if you take x in common, I'm going to get pi by 4 plus 2. So isn't that what they are asked to prove? Yeah, 2 plus pi by 4, that's the same thing. So this is what they have asked to prove. Okay, so this is a 4-mark question. So the first method mark is for the correct substitution or finding the expression in terms of y. So if you do that correct, you'll get the, for the method you'll get the method mark, and for the accurate answer you'll get the accurate mark. It need not be expanded form, it's just a simplified form is enough, and after that you need to plug in that y value in p to get the accuracy mark. Okay, now the second method mark is for the expansion, the correct expansion of this term, and the accuracy mark is for the correct answer that is required in this format. Okay, so that is all about part 2. Okay, in the next part of the question, they are asking you to use algebraic differentiation to find the value of x that gives the minimum value for p. So the minimum value for p, we need to find which value of x gives it. Okay, so what we need to do is again differentiation of p with respect to x. So we already got p over here, so we can differentiate with it with respect to x. So this is equal to p, and dp by dx is what you need. Okay, so this is actually a constant, and we know that the derivative of 1 by x is equal to negative 1 by x square. So the first term, this is the constant, and then you taking the derivative, it will be minus 1 by x square, and the derivative of x is equal to 1, whereas this is a constant. For example, you imagine that this is actually this is equal to 5, so you are taking the derivative of 5x, which will give you 5, but here instead of 5 it is this constant, so it is that constant that you are going to get as the derivative. So this is equal to the derivative. Okay, and here also you can take it like that. Here also you assume that this is equal to 5 over x. Okay, so the derivative of 5 over x is equal to negative 5 over x square. So the negative, this instead of 5, this is the constant we are taking, so negative of this divided by x square. So that is how you identify or like easily clear your doubt in case there is a complicated expression. Okay, so this is the final, sorry, the initial expression for the derivative. Now we know that it is a minimum value, so we have to equate it to 0. So that is 20,000 minus 25 pi times negative 1 over x square plus pi by 4 plus 2. So I'll bring this whole term to the left so that this negative will disappear. So I have 20,000 minus 25 pi divided by x square, or that is actually the same as times 1 over x square, which is divided by x square. Okay, so that is equal to pi by 4 plus 2. So now I need to find x value, so I just bring this term to the other side. So that is 20,000 minus 25 pi is equal to pi by 4 plus 2 times x square. Now this term I can bring it down and take the square root, I'll get the value of x. So x is equal to 20,000 minus 25 pi divided by pi by 4 plus 2. If you solve this on your calculator, you're going to get 84.57, which can be rounded to 84.6 because they mentioned the value to round to 3 significant figures. Okay, so the first mark over here is for correct differentiation. So if you do the differentiation correctly over here, that is this step, you will be getting the first method mark. The second method mark is a dependent method mark based on equating this to 0 and rearranging it for x. So that is the second method mark, and the final accuracy mark or the answer mark is for the correct answer for 84.6. Since they have specifically mentioned 3 significant figures, you have to write it in 3 significant figures itself. Okay. Okay, now in the last part, they have asked to first consider the second derivative and then use that to justify that the value of x in part C will give the minimum value for P. Okay. So first of all, we'll find the second derivative. We already found out the first derivative over here. So this is the first derivative, and here these two terms are constant. So when you take the derivative of the constant, that is going to be equal to 0. And then I'll write down the derivative of this term also. So the derivative of 1 over x square, or the derivative of x to the power negative 2 is equal to negative 2 times x to the power minus 2 minus 1, or it is negative 2 over x to the power 3. Okay. So this is x to the power negative 3 here. Okay, that's fine. So we'll take the derivative of this whole thing. So I told you from this thing, this is a 0. The derivative of the constant is 0. So you don't need to consider the derivative of this part. Only you need to take the derivative of this part. So we need to take the derivative of, I'll write the whole thing still in case you have a doubt later on, you can refer to that. Times minus 1 over x square plus pi over 4 plus 2. Okay, so the derivative of this will be 0, and the remaining part, the derivative, this is a constant, so we'll keep the constant outside, and there is a negative also, and the derivative of 1 over x square we found over here as minus 2 over x cube. This is the negative sign for this one, and this negative belongs to this term, the derivative term. Okay, so this is the second derivative. So that is d square p by dx square. We'll expand this, so this is going to be positive, and when we multiply the 2 inside, so that is going to be 40,000 minus 50 pi divided by x cube. Okay, now if you observe here, the x value was positive, and 40,000 minus 50 pi is also going to be positive. So this term is positive, this term is also positive, because they have mentioned that for the x value we got in the previous answer. So the previous answer was 84.6, right? For the x value found in part C, which was 84.6. So that value, if you plug it into this expression, d square p by d x square is going to be greater than 0, or it is going to be positive. Okay, I hope you understood, because this you can try it on a calculator, it is going to give you a positive value, and the cube of a positive number is also going to be positive. So this gives you a positive value, therefore it is going to be a minimum value. For a minimum value, if the second derivative is greater than 0, we can make sure that it is a minimum value. If it is less than 0, if the second derivative is less than 0, then we say that it is a maximum value. Okay, so I hope that was the last question for this paper. Okay, thank you so much.